alarm, and the guys will do their best to answer them for you. And we will have a recording of this session as well afterwards if you want to go back and watch any bits or share it with a colleague. Okay, so without further ado, I will hand you over to the team.
Great, cheers, Stu. So, morning everyone, welcome to today's webinar. This is an extension to the previous one that we did, which was just a very brief overview of the key features. But today we're going to have a live demo of the software and get to see how it actually processes stuff from Abel. So Abel is our geospatial technical support for the Southeast, and I am a senior applications engineer at Korec here. So yeah, as Stu has said, just ask any questions as and when they come up. We'll do our best to answer them during. If we can't answer them during, we'll get back to you later on. So the things we're going to cover on this presentation will be how to manage a project in CloudEngine, how we'd import our data, some different file formats and how it will merge it all together, and the visualization tools, how we manage the point clouds in CloudEngine as well. And then we're going to show some nice tools that will help you clean your point cloud data sets, how we can publish this data online, share it to multiple different stakeholders, and how we can do heat maps for 3D inspection. That would be against models, against another scan. We can do all these sorts of things in CloudEngine. We can show you the 2D as-built delivery. We'll also show you there's quite a nice feature. So we've got the EU standard for floor inspection, floor flatness in there as well. So Abel's going to run us through that later on. And we also have the Autodesk application integration, which is a really nice feature. So the value proposition, before I hand over to Abel, so the value proposition that we see for CloudEngine is to split it into three here. So simplify, verify, and collaborate. So to simplify, we have point clouds that have been around for many years. Up until recently, they've been very niche and very challenging to manipulate. So with CloudEngine, whilst it's packed with all these really complicated features, it's really user-friendly. And from the import to the verification, all the way to the final publication. So verify. When it comes to the 3D models and as-built data, there's plenty of different solutions on the market, but Trimble CloudEngine does exactly this at a price point which won't scare people away. You know, we can verify our 3D models to as-built data and provide an array of very visual reports. So collaborate as well. The sharing of our point cloud data is notoriously difficult due to the file sizes. So there's a compression ratio of about 90% in Trimble CloudEngine, which Abel will show you. So CloudEngine allows the sharing to be done on premise or on Microsoft Azure servers. So we can put that to a public-facing web page, or we can just send it locally into little files. So without further ado, I'm going to hand across to Abel, who's going to walk us through some of these key features, and he's going to help us out. And, you know, as the questions come in, I'll keep an eye out on them while Abel's doing his thing. And as many as I can answer, I shall answer. And anything that we need Abel to jump in on, he'll jump in on. So over to you, Abel.
Thank you, Sam. Hello, everyone. So we're going to start with Trimble CloudEngine. As soon as we open the software, that's the windows that we are going to see. So the main menu is here at the top left corner. As soon as we select that one, we are going to come to the main menu where we can manage all our jobs and or our projects. In that case, I'm going to start with a new one. Just hit the button, create a new one. And as soon as you hit the button, just give a name to that project. And press enter. For whatever reason we want to go back to any of those projects, we can just quickly select, hit the three dots here and go back to any of those projects. In that case, for this example, we are going to work in global coordinates. Almost nowadays, all projects start to work in global coordinates. As well, we've got always the import button there, but I really love the option to drag and drop. So at the moment, our project is completely empty. Here at the top, we've got all our tools. As soon as we select one of the tools on our right-hand side, we are going to see the tool menu. Underneath the tool menu, we've got the object list. So as soon as we import scan data, we are going to see all those data here, all those scans. As soon as we import the 3D model, or as soon as we create any analysis, we will see all objects directly here underneath in our object list. At the very top, we've got the visualization tools that we can quickly do a thumb extension, see the top, change from orthographic to perspective view, or 360 to the classic station view. So I'm going to escape of that tool. I'm going to move the software to here. I'm going to open my data. So here I've got two TZF scans and just drag and drop. TZF is Trimble scan data. I'm going to import only two scans just to make the demo very quick and don't spend a lot of time importing or analyzing all the stuff. Here it is, the point cloud. Just quickly, I'm going to show you as well the help menu that we've got here in Trimble CloudEngine. Is an online help, so the help will be always updated with the latest release. And something that is very nice from the help, and is something that is worth it to mention. If you want to do, for example, the site validation, and you don't know how to use it, instead of spend a lot of time reading through the manual, we've got a lot of videos where you can see how the software is working. And in that way, you can quickly learn by your own on how to use that software and apply. At the same time that we are here in the help, I'm going to show you what formats are supported inside of Trimble CloudEngine, FLS, point clouds, obviously Trimble TZFs, recap files, so we can import recap projects straight away to Trimble CloudEngine, standard formats like E57 or LAS and LAZ, and other formats like PTX, etc. Of course, topographic data as a TXT or ASCII or PTS files, and for design 3D models, we can import as an IFC model, DWG, DGM, and another formats. If you are working with Revit or AutoCAD or Navisworks work, we've got an app that allow us to send the data in both directions, from AutoCAD directly to the CloudEngine or from CloudEngine directly to AutoCAD. So if you create your own report, we can send that report back to AutoCAD. The same with Revit and the same with Navisworks. So if you want to send the model to Trimble CloudEngine and you want to compare your model against the point cloud, just send the model straight away to Trimble CloudEngine. Okay, I'm going to close that help and let's start working with the point cloud. The first thing that I'm going to cover here is how we manage the data. So I just track the points and immediately I can see the points. What I'm seeing is not the full data, okay, it's just a small preview. How Trimble CloudEngine is working is a bit different than all other software that we've got in the market working with point clouds. We can select how much data we want to display. So for example, 7 million points, and it will automatically upload and display those data. Okay, so in that way, allow us to work with all data or just with a few data and change the resolution of it very quickly and very straightforward. Always we can come here to the Raw tab and import the full data. In that case, 2 scans is just 23 million points. Here you can see the 2 stations. That's the first thing I'm gonna show you. So we can as well, not only working in perspective, as well we can jump to the station view. And as well we can optimize the size of the point cloud, change the brightness as well, a little bit exactly the same as many softwares in the market that are working with point clouds. We can change the visibility of those points. In that case, those scans are a gray color without picture, so we cannot see the real color. I'll show you later on another point cloud with color. We can select different color codes. In that case, I'm gonna give a color per scan, so you can see both scans, one in red and the other one in green color. As well, we can change the brightness in order to see the difference between all bricks, etc. Just click apply. And the next step normally is going to the registration. And in the registration, we can do cloud-to-cloud registration as almost all softwares in the market. We can use black and white targets, obviously, as well as spheres. And something as well that is very nice in Trimble CloudEngine is that we can, if for example we want to compare a 3D model against a point cloud, and that model is a precast concrete model, normally it's a bit difficult to place everything in the same place. So what we can do is run the best fit between the point cloud and the 3D model. At the moment you can see both scans are already in the correct position, mainly because that scan has been done with the Trimble X7, so the registration has been done already on site while we are scanning with the Trimble X7, and as well is georeferenced because we use the laser that we've got in the X7 to compute the position of the scans. So here we've got all the tools that we can use to register scans together or against a 3D model. I'm not going to spend more time working with the registration because it's already done, so I'm going to jump, and it's nothing different than other softwares in the market. So I'm going to jump to the another quite basic stuff as soon as when we are working with point clouds, that is the clean part. So normally we spend a lot of time trying to clean the point clouds in order to do our analysis. We've got the same tools as other softwares, the classic rectangle selection, the polygon selection, another one that is called lasso. But something that is unique in the market right now is the brush, and that one is very, very useful, because if we are working here in that example and we are trying to clean that data, normally we need to cut the data in order to remove those points. However, with that function, with the brush, I'm going to increase the size of my brush. I can select this balustrade without selecting the points that are behind the balustrade. So quite quickly, you can select all those points. And I'm not worried because I'm not selecting any point behind the balustrade. Okay, and just press delete. So I'm gonna delete all those points only. So this tool is very, very handy It will allows me to speed up my clean data. Always try not to spend time cleaning the data because it's the best way to lose time. Okay, another nice feature that we've got here, showed you earlier that we can change the resolution of our point cloud. And at the moment I'm working just with 1.7 million points. What happened if now I want to work with this wall and I want to do an as-built of this wall and I want to use all points? I'm gonna trying to bring more data. So when I bring in more data, as you can see here, even though I'm changing the resolution, the data is still clean. Normally in other softwares, when you increase the resolution or when you bring more points, suddenly you find out that you need to clean again the data. So it doesn't matter if we change the resolution, the amount of the data that we are displaying, the data it will still be clean. Another fun, nice tool that we've got is using the brush. At the same time, if we want to remove, for example, that pipe, just select a few points along that pipe, and we've got the grow selection option, and it will automatically select the points along that pipe. So in that way, it's not only selecting the pipe, it's as well selecting the channel that is there to hold the pipe straight. So again, just press delete and it will delete that data. So two nice features, the brush and the grow selection tool. So before I start working with that one, what I'm going to do is create a section box. I'm going to ask to display only the data that is inside of the section box. And from a top view, I'm going to first of all rotate it to align the box with the walls. Move it to the correct place, and I'm going to change the size. So in that case, I'm going to remove all the data from outside the window. That's something that we are still having points through the glass. And I'm going to remove the ceiling as well. So we are going to work with the walls inside, the columns, and as well we are going to analyze the floor. Here you go. I'm going to save that section view. So now we can work in that section view only. Okay, before keep going with this model, I'm going to jump to another project. I'm going to show you another option to clean our point cloud even quicker and faster than what we already saw. I'm going to jump to the other project. I'm not going to close that one. You can always save that project. And I'm going to jump to this other project that I've got already open. It's already open because it's a few scans more. And it can take longer to import all the data. And I just want to show you how easy it is to clean the data. So can you imagine if you've got a full floor where you are doing the demolition and what you are trying to do is compare and check if all this steel structure is in the correct place. How long is going to take you to clean all this data to just display the columns and the beams? It will be a very difficult task, and it's going to cost you 1 day, 2 days to clean all this data. So in Trimble CloudEngine, we've got another tool that allows us to clean the data that is close and keep only the data that is close to the model. So let's go back to the full view. What we need to do is just here on our object list, select the 3D model, right click, and select by shape. And in that case, I'm going to ask the software to select all points that are within 1 inch from the model. And in just a couple of seconds, it will select all those points.
While that's processing, Abel, we've had a question come in.
Yep.
You're probably better to answer this than me. So we're wondering whether it's possible to create different point cloud groups for walls, ceilings, floors. Is that possible in CloudEngine?
Yes, in fact, we're going to create now a new group. That's well done, just on time.
Great timing.
So it's already selected. You can see all those points very close to the beams are in orange. When the points are orange, those points means that are selected. So what we are going to do is that one. I'm going to invert this. Well, yeah, let's copy those points, and in that way we will create a new group. I was about to invert the selection and delete the points in between. So I'm gonna try to copy that point cloud. Don't know how long it's gonna take that one. Hopefully it doesn't take too much. So even though I'm working with a preview of the data, the software at the back is working with a full cloud. That's why you can see that it's taking a bit more time than just working with the preview data. What is nice because allow us to work with any type of laptop. Doesn't matter if it is not a high spec, the software will work. Any other question while we are waiting for the one? Saving process file. Well, I don't know if you can see at the bottom is where we've got a process bar, and here it is, our copy. I'm gonna change the name, and I'm gonna call it point cloud. I'm going to hide all the scans, 5 of them, so hide all of them in one go. And here it is. I'm gonna hide as well the 3D model, and now you can see all our point cloud completely clean and ready to compare that point cloud against the 3D model. How to compare that one is just use the tool Cloud Calculated Deviation Map and Report. I'm not going to run that one here, mainly because it will take around between 10 and 20 minutes, and I don't want to waste your time. So I'm going to cancel that one. What I'm going to show you is the classic 2D as build. So I'm going to use a horizontal plane that we've got here, that is 1 meter from the finished floor level. And we are going to use that plane to create a horizontal slice, cut the 3D model. When we cut the 3D model, we are going to have a few blocks, cutting those columns, 1 block per column, and the software will automatically look to do a best fit of that block against the point cloud. So to that, we are going to go here to our customize tools. You can create your own tools. So what we need to do is just select the horizontal plane and hit the section offset tool.
So while that's going, Abel, we do have a question that's come in about the size of the coordinates that we would use. Are we able to use coordinates that are in an ordnance survey, for example?
Yes.
Yeah. There's no problem at all processing that. We don't need to keep it local to 00, do we?
No, definitely not. That's why at the beginning I select glove.
Yeah. So any coordinate system
It will work. Yeah.
fine. Great.
I'm just trying to open at the same time AutoCAD because I'm going to try to export the data directly to CAD. Here we go. So here in the coordinate system is where we can change to globe coordinates. If we leave it as a project, it will be local coordinates. Both options are supported. It's taking more time than expected, sorry. While it's finishing, I'm gonna show you our Trimble Cloud Explorer. Okay, so we can publish the data, and I'm gonna show you how to publish the data. And we can see the data directly using any internet browser, so we don't need to install anything. However, we can install as well on our desktops the Trimble Cloud Explorer, and we can, from the server, just select any project and jump on that project and see absolutely everything. So that's the same project that we are working on it at the moment. So we can create different groups, different views. So in that case, I've got the full data there, so everyone can jump and take measurements and work and see all the full point cloud, or as well they can see the full data, just the clean data, and they are going to be able to jump in the station view and see as well everything there, take some measurements. It's a very useful tool.
So I think something worth mentioning here, Abel, is that
Yes,
this doesn't have to be stored locally either. So if you've got this on an Azure server, we could give the install package, give the credentials to log into anyone within a business, and they'd be able to stream that data off of the Azure server as well, locally on the computer, rather than having to go through a web browser.
that's correct. In fact, I'm working with that data, and that data is coming from from Azure, Microsoft Azure directly. So I'm not that data is not stored in my laptop.
Yeah.
So here in my settings, you can see that I'm working with Microsoft Azure.
Yeah. Are we able to store it on Google servers, Abel? We just had a question come in. Or does it have to be a Microsoft Azure server?
At the moment, as far as I know, is Microsoft.
Okay.
But it can change in the future. In the past, we have been working with Google Drive. Now is Microsoft Azure is a little bit more safe, and it's much easier to share the data around the world.
Yeah. Okay.
Here we can see a project, for example, that is from US. A lot of scans there, and how easy it is to manage the data and how easy it is to move around the project.
So in this Abel, we could asset tag, could we? We could add some comments and stuff like that to the data. Would other people be able to see that as well?
Yes, you can add some tags. Yeah, thank you so much. So yes, you can add some tags.
Okay.
We can add PDF drawings, attach some files as well. Okay.
Oh, great.
Almost done that one. Here we go. So I'm going to hide the horizontal plane and as well the 3D model and our point cloud. Here we go. So I'm going to keep the point cloud. Here we go. So if we do zoom in, you are going to be able to see two sections. One is coming from the, let's see if that one is much easier to see. Yeah, that one is much clearer. Keep in mind that I'm importing only 5 scans, not the full scans for this floor, so a few columns may be wrong. So here we can see the correct section. So you can see where is the design section and how the software moved that section towards the point cloud, trying to match the best fit. So we can hide and display each of one. I'm gonna show you any other point cloud. So for example, that one, that's definitely much clearer, much easier to see that one. So that's the section from the 3D model, and that's the correct section. And if we twist that one, you will see how the section is perfectly matching the point cloud. Okay, so as soon as we've got that one, that analysis, and we need to send that one to our CAD, what we can do is select everything, came to Autodesk, open a new project or an existing project, and just ask to import the data. Select what we want to send to CAD. Great. 1 second, sorry. AutoCAD. I'm gonna open the AutoCAD again. That's something that can happen when you are doing a live demo. Here we go. Trimble CloudEngine, import. Go back to Trimble CloudEngine. Select what we want to send to CAD. Just send the data to CAD. And here it is, all our data. Let's go to a top view quickly, and we can see now here all the sections and as well the point cloud. So if we go back home to the layers, we will see all the layers there, and we can hide or display wherever we need it. Okay, I'm going to close that. And I'm gonna go back to I'm gonna go back to our previous project. Concrete structure. Oh no, sorry, that's not the project. Go. So we were here. I'm going to keep working with my section view. And the next step is how to import a 3D model. Again, just drag and drop. This is the best option here in Trimble CloudEngine. Is the quickest one, or at least the one that I really love. Really like it. And we are going to do an as-built of a few columns or a few walls. I'm going to show you how to create a report and how to publish the data, because sometimes it's not just sharing the point cloud and the scans as well. What we want to share is the reports and the analysis, so everyone will be able to walk through the point cloud and see all the analysis, and it will be much easier to understand where is that column that is completely out or where we've got all these problems. Here it is, the model. The model is in gray color. Here we can see there are a few walls and a few columns all around here. So I'm going to try to work with those walls there. For that, what I'm going to do is create a new section box. I can even remove the points from those pipes, but I'm going to leave those points from the pipes, so you will see as well another option that we've got. I'm gonna save that section box. I'm going to select just the scan data. I'm going to create a group. I'm going to call it scans. There you go. I'm going to reduce to 1.7 millions just to speed up all this demo, only for that. And I'm going to go directly to the deviation map. What case I'm going to work with only 2 mil just to get some ROM values. If not, we will be looking for 5 mil, 10 mil, depends on your construction site tolerance. So 0.002, and for the maximum deviation, I'm going to set that one to 15 mil. Let's hit the button to do the analysis. The maximum deviation means that all those points that are far away, more than 10 mil away from the model, it will be ignored. So now you can see that those pipes are in gray colors. They don't have color. They are not colorized. So it means that they are outside of our maximum deviation. So that's another way that we don't need to clean absolutely everything. We can just run the analysis and crack on. So I'm going to hide the model so we can see the full point cloud. And we can see now how those walls, by the way, these walls are precast walls. So those are a little bit tilted and twisted as well. So what we can do now is not only publish that option, that data, we can as well add a few points. Normally, if you're working with precast, we are going to analyze 4 corners and as well in the middle. Or you can choose a few points where is green, where you've got different colors, or wherever you prefer. You can customize what points you want to analyze. And just reduce that one. And the good thing is we can create a report straightforward directly to Excel, and it will open the Excel directly. Here in Excel, we can customize everything. So we can, using macros, I strongly recommend to use a macro. We can customize this report, stick our company logo, etc. And we will see all those points there, and as well, all those points will be here. So quickly we can see that the maximum deviation is, in that case, is 7 mil, or sorry, 9 mil there. Okay. Another option that we've got, that can be later on, don't save, printed in as a PDF. But another option that we've got is the publish. So with the publish option, we can just, as soon as we do any analysis, we can just click publish, or in that case, I'm going to display the point cloud. I'm using the section view, sorry. I'm going to apply the other section view, set model view. So I'm going to see the full point cloud. And like that, I'm going to publish that data. How that is working, we are going to create different views, and the software will automatically show us that view in our favorite internet browser. So we can analyze and see if that's the correct view. So here, all those points are going to be as well exported there, tagged to the point cloud, so everyone can click in that point and see exactly about how much is out that wall. So in that area that it looks like is the worst one, we can see there are 6 mil. That is, it will be one view. So if we are happy with that one, here in our object list, in the publish section, we can change the name of that one. So as all, and as soon as we've got all our analysis, all our views, what we need to do is just came here to the upload and just hit the upload button, and everything will be uploaded to the Microsoft Azure. So from that moment, everyone will be allowed to see the data. Next step that we're going to do is work with the floor. We are gonna check how flat is that wall, that floor. For that, I'm going to do another section view. So I'm going to remove all ceilings quickly. Right, that's great. I'm going to as well create a plane. And the plane that I'm going to create, it will be the best fit to just this area. I'm not going to pick the entire floor. Normally, we are working and doing a proper analysis. We will have more than 2 scans. Again, I'm using only 2 scans just to speed up everything for today. So I'm going to do a best fit to those points of one plane. Right? We can edit the properties of that plane and move it to the correct elevation, to the elevation of our finished floor level. I can't remember which one is the level, so I'm gonna leave it like that. The unique thing that I'm going to do is rotate that plane, best fit plane. There you go. That's done. So we've got our reference, that is going to be the plane and as well the point cloud. So again, just select the point cloud and go into our analysis tool. Define our tolerance. In that case, the tolerance and maximum deviation is going to be a little bit high. Sorry, I don't know why I've got my Outlook open. I'm going to set that one maybe to 30 mil and around 0.05 mil. Just hit the button to analyze. If we don't want to see the fit plane, sometimes it's worth it to just change to the wireframe. So in that case, we're going to see only the point cloud. Maybe that is too much. I'm going to change to 20 mil. I would see some differences, different colors. Here we go. So now I've got some reds as well, a few blues, a little bit of different colors. Normally, you're going to look to analyze the floor with your tolerance and with your maximum deviation. Just saying, that's a sample. I'm trying just to give some colors and show what is going to happen and how we are going to work with those areas that we've got some differences. So that is already done. I can exactly the same as we did with the walls, we can add some points, publish that one directly to the Excel. And as well, as soon as we go doing more and more analysis, we can have the different tabs, and we're going to be able to print all of them in one single PDF, not a lot of PDF by each analysis. I'm going to close that one. Normally, when we are working with the floor, we are looking to get some grid points. To do a grid points, what I'm going to do quickly is going to the sketch tool. Here we've got different options to draw different elements and best fit different elements to the point cloud. In that case, I'm going to work with that plane. So select the correct plane, and I'm going to create a grid every half a meter. My point grid, and as well I'm going to create a line grid. Here we go. So now we've got our grid. Cannot see it. Let me edit the section view. Yep. Now I can see the columns and the rows. So what we need to do now is coming back to the analysis and select our grid points and ask the software to analyze the floor at that level. So now we should be able to see some deviations, and those deviations is the ones that we can send to Excel. Sorry, it didn't work properly. 1 second. I need to select the grid points, compare it against the point cloud to get the differences on those elements. Draw the spikes. Let me increase the spikes. Okay. Sorry, I don't know why right now it's not giving me the values. But the idea is just press the Excel button and I'm going to have a result like this one. So I'm going to have for each row and for each column a value in each area. I don't. That example is not. I'm not getting a value in each cell mainly because we don't have point cloud in every single cell. That's why we can see a few empty cells there. But that's the kind of report that we can create just exporting these grid points. As well, the other option that we've got is we can select those ones and export publish that one to our server. So quickly publish that one. And we're going to be able to see. So I recommend to hide them up. The plane, sorry. Let me hide the plane again and export it again. Here you go. So we can publish all our analysis. Another option that is even more, can be more interesting, is if we open a floor plan, an existing drawing, we can overlay our analysis on top of our floor plan. I'm gonna send that one to cut. And we will see those points as well with the differences. But definitely we need to change the edit the test. And if we want to see the point cloud as well, we're going to be able to see the point cloud. Okay, so that allows us to keep working inside of our software. Can be AutoCAD, can be Revit, or other softwares as well. We can export the points and all the analysis straight away to our softwares. So we can plot everything directly from here. That's it from me. It's a very quick view, and yes, we cover only 5%, I'm gonna say, of the software. There is more stuff here, but we want to keep it a bit a small demo, not a very big demo.
No, I think, yeah. So
any questions so far?
I've got a couple that I've got for you, Abel. So yeah, thanks for that overview. A couple of questions that have come in whilst you were doing your thing. So can the updated positions of the analysis of, you were looking at the columns, can we export those updated positions as an IFC, or is it just a 2D slice?
Export it to an IFC.
Yeah.
If we can export that one to one of those softwares, Autodesk, Revit, or Recap, and then it can be exported directly from there to IFC.
Okay. Are we able to upload to BIM 360 out of CloudEngine?
Sorry, say again, upload?
Are we able to upload to BIM 360 automatically, or would it have to be a manual process?
BIM 360?
Yes.
Sorry, I don't know what's BIM 360.
Okay, it's an Autodesk sharing platform.
Sorry. Don't know about that one.
No, we'll have to get back to you on that one.
Yeah, sorry.
Not too sure. So can the grid point deviations be displayed on the point cloud as well? For your finished floor.
Display the grid point on the point cloud.
Yeah, display the deviations from the grid onto the point cloud. Is that possible?
is already here. The text is too big. Let me. Those are the deviation points. Can we see that is 52, 61 mil? I need to change the text
The text
size.
because it's back to front as well.
Yes, I don't know why it's in the other way around, but
yeah. So floor flatness and floor levelness. Yes, we are able to report on both of those features as well.
Yeah.
So that's just rather than doing the heat map against a plane, we can choose the floor flatness, floor levelness reporting as well. So that does come out as well.
Yeah, the floor flatness is another tool that we can cover in another session as well.
Yeah, it'll take, there's quite a lot to do on floor flatness, and obviously we want to try and keep this nice and short. So yeah, thank you, Abel. I mean, if there's any more questions and you keep them coming through, I'll just quickly go back to where we were. So is that flashing for anyone else, or is it just me?
Flashing for me as well.
Great. There we go. Okay.
Nice.
So yeah, so thanks for the demo then, Abel. So moving back, so we can just quickly review the value proposition, and then we can just chat about the costings and the packages that we can do on this one again. So we have simplify, verify, and collaborate. So hopefully Abel has shown us how all those features are possible today. That that's not exhaustive. There are plenty more features that we can do that we've not been able to show you today just due to the timing. So we can hook up at a later point, and we can definitely get more in depth with you guys. Just get in touch and we can show you it. So moving on. So if you were on the previous webinar, you'll be familiar with these two packages. So we have a review and a design package. So the review package is essentially just for processing your data, combining data sets. You've got the simple geometric shape fitting in there as well. But when we want to do the deviations and the demolition modeling, we're moving into the design package. So if you just want to check a bit of data, review is okay. But if you want to go for the deviation mapping, use the floor flatness, use the clash detection and all this sort of stuff, that'd be in the design package. So review is from about £100 a month and on an annual term, and design is from about £325 a month on an annual term. So, hopefully that's a nice overview of the product itself and how we can help you out with that. You've got a live demo from Abel. And if you want us to come and show you your data, and we can do a presentation very similar just to your customers, just to you, and we can do that. If you could get in touch with us on the info at Korec Group, I'm sure you probably all got myself and Abel's contact details anyway. So just get in touch with one of us. We can certainly hook you up with that. If you want demo licenses as well, not a problem. And if you want us to share some data on the web, again, we can talk and we can go through that as well. So yeah, I mean, that's a very, very quick overview. If there are any questions, just put them through in the chat. I think we've covered most of them. I'll just quickly check. So we had a question that was asked quite a few times on what the point cloud formats were. So your point cloud formats, I'm going to very quickly read through them all. So we've got our TZF, which is our Trimble format, FLS, ZFS, RCP, E57, PTX, ZFC, DP, LAS, TXT, ASC, and PTS. So, there's pretty much every single scanner and software is going to be able to get into this. without much effort at all. Do we have any? Yeah, so this session has been recorded. So for the people that weren't able to join us or want to review later on, we will send you a link across to review this with whoever within your company, organisation, or other partners. We are able to create different point cloud groups. We have covered that. Hopefully, Abel, we did show that. So hopefully you managed to catch that one. Yeah, I don't think there's any more questions. If everyone's, if you have any more questions, you have our contact details, just drop us a message, get in touch, and we can go from there. So I hope you've enjoyed today. And yeah.
Thank you so much, everyone.
Thank you, Abel.
No, it's a pleasure.
Thank you. So yeah, just get in touch if you need anything further from us. Thank you.
Take care. Cheers.
Cheers.
Bye.